Welcome. This session we'll try solve a sample question on equilibrium of a general case of force system. So here I take this question. Determine the reactions at the supports for the loaded member shown below. So you see this member AB, supported on a roller left end, hinge right end. Okay. So the span of the member is 10 meters. Loads, if you see, there is 50 kilonewton load at an angle of 40 degree with respect to the axis of the member, and at the middle 80 kilonewton vertically downward load, and 3 meter from right there is 60 kilonewton load with 30 degree with respect to axis of the member. Okay, so you see, first thing we need to do is we need to draw a free body diagram. Okay, just try FPD. Okay, so just try draw the member first, then we try draw the reactions. See, this is a roller, so I expect only one reaction. As this is a hinge, I try expect the two reactions to occur. Okay, so because of the hinge, right? So I call this as say reaction 1, we call this as reaction 2, call this as reaction 3. Yeah, now you draw the forces given. So this is exactly the midpoint. Let me go with a different color. So this point, it is the 80 kilonewton. Okay, then somewhere here, now 2 meters. So we have a 50 kilonewton at an angle of 40 degree. So this point is at 2 meters, and this is 3 meters between these two. So these are the loading spans that you have. And then again 2 meters, you have a force at 30 degree, inclined force 60 kilonewton. Okay, yeah, the spacings 2 meters, then 3 meters. Okay, yeah, now you see this member AB, which has got total 6 forces, 3 applied forces and 3 reactions, which will not pass through a single point. Okay, they are non-concurrent forces and non-parallel forces. So we call it as a general case of force system. Yeah, now let us resolve the inclined forces into components. Okay, so you see the lecture that I have now posted on how to resolve the force into rectangular components. So this is horizontal component and this is vertical component. So this is a 50 cos 40. This is 50 sin 40. Okay, towards the angle it is cos component and away from the angle sin component. Same way you try go with the two components for 60 also. So this is one component and the other component. Okay, so this will be 60 sin 30 and 60 cos 30. Yeah, so this is the next thing to do. So first we draw free body diagram, then we resolve the forces Okay, because the forces are inclined. Yeah, now as the bar is stable, which means equilibrium, we'll try apply equilibrium equations. Okay, so for a general case of force system, you can apply three equilibrium equations. Okay, so first one is let us say sigma fx 0. Second equation we apply sigma fy 0. The third equation sum of moments is 0. Okay, you can apply either these set of equations or uh, one force equation and two moment equations or all three moment equations. So whichever set is okay for you, you can choose that set of equations, but three equations. Okay. Yeah, applying first one, sum of x forces is 0. So consider direction as positive. Okay, let us say rightward forces are positive. So this here you see the horizontal forces are from, if you come from left end, so it is 50 cos 40 is the component of 50. Then this one is opposite towards negative side. So 60 cos 30. This is also negative, minus R3 is equal to 0. So if you work out this value, this is 38.302 minus 51.962 minus R3 is equal to 0. So working out, we'll get R3 value as minus 13.66 kilonewton, which means that the direction that you assumed here, okay, is not correct. So you just correct that direction. So which means I'll correct the direction. 13.66 kilonewton acting towards the right. So this is the exact value and its notation. Okay. Now applying the second equilibrium equation, sum of y forces is 0. Just look for y forces here. So component of 50 and 80 and component of 60. Okay, so these three are vertically applied forces and R1, R2 are the reactions. So total 5 forces are in vertical direction. So I'll try write them. So choose any direction as positive. I take upward forces as positive. So R1 is upward here. So let us say R1 plus R2 is also upward. Remaining all are downward. So minus 50, component of 50 sine 40, and 80, the direct vertical force is also downward, and minus 60 sine 30, total sum shall be equal to 0. Okay, so we'll try pick R1 plus R2 minus, solving for those values, 32.14 minus 80 minus 30 is equal to 0. So we get R1 plus R2 value as 142.14. Okay, right. Now applying the third equation, sum of moments shall be 0. So you need to choose two things here. One is moment center. I choose point A, and you need to choose the direction. So anything like clockwise or anti-clockwise, whichever you like, you can have it, okay, as positive direction. Okay. So coming from left, okay, I'll try plot the beam quickly here for the reference to write the moment equations. Okay, so to not to go back to that page again. So this is R1, R2, now R3. Exactly at the middle we have 80 kilonewton. Okay, then we have 50 kilonewton, 40 degree. We have 60 kilonewton at 30 degree. Okay, yeah. Now let us see. We have resolved the components also. I'll just quickly write the components, the two components here and the two components here. Okay. So writing moments now is 50 sine 40, 60 sine 30. So I take this point as moment center. You can choose any point, okay, on this line, right? So I choose this point. So from this point, what are all the moments that are being created by all these forces? Okay, so if you see R1, the distance is 0, so it can't create any moment. So this is 0, right? Then coming to the 50, now it is two forces, horizontal and vertical. Horizontal force passed through A, so no moment from this component, whereas you have a moment from this component. So this is 2 meters, this is 3 meters. Again, this is 2 meters, and this is 3 meters. So this force will try to rotate this member in clockwise direction. So it is plus, okay, 50 sine 40 is the force into the distance 2 meters. Clockwise positive, so this is clockwise moment, this is positive. Coming to 80, also clockwise, because this member is being rotated with this 80 by clockwise direction. Okay, so 80 into distance from A, distance is perpendicular distance is 5 meters. Okay, similarly 60 sine 30, 60 sine 30 clockwise, this is also clockwise. Okay, perpendicular distance 3 plus 2, 5 plus 2, 7 meters. Okay, then this component will again pass through A, so no moment, right? And R3 also is going to pass through A, so no moment. R2, okay, is going to be this member about this point. This member is going to be rotated in anti-clockwise direction. So R2 into the distance is 10 meters, which is negative. So by solving this, we get R2 value, which is equal to 67.428 kilonewton. Okay. Now substituting R2 into the above equation, this equation, we get R1 as 74.712 kilonewton. Okay. So these are all the reactions that you can get. R1, this left hand reaction, R2 and R3 reactions. So this is how you are able to solve a general case of force system with the equilibrium concept. Thank you. We'll be back with the next example.